Hello everyone, I hope you are getting my videos. Dear students, we have finished our unit 3, that is magnetism, and now today we'll discuss some conceptual questions, and at the last we will write some key points, means the formulas and one word answers of unit 3. Okay, so let us start our today's work, that is conceptual questions of unit 3. So you can see on your screen that first question is, what is the magnetic force experienced by the stationary charge in uniform magnetic field? Means what is the magnetic force which a stationary charge will experience. So students, I told you in the beginning of the chapters only that moving charges means currents, they produce magnetic field, and stationary charge can produce only electric field. Stationary charge can produce only electric field. So that means the force which a stationary charge will, magnetic force which a stationary charge will experience, it will be equal to 0. But you have to write in systematic way. You have to write that we know force F is equal to BQV sine theta. As it is written over here, F is equal to BQV sine theta. Now the charge is stationary, that means it is not moving, means velocity is equal to 0. Put this velocity is equal to 0 in place of this v, so F will also be equal to 0. Okay, if in one MCQs it will come, then you can directly take the answer, but if this question will come for 2 marks or 3 marks, then you have to do it stepwise. Okay, now let us proceed towards the second question. Find the magnetic force if charge is moving in the direction of magnetic field. If charge is moving in the direction of magnetic field, means velocity and magnetic field both directions are same. So students, you know that if direction is same, that means angle equal to 0 degree. If direction is opposite, angle is 180 degree. Direction is same means both are moving in the same direction. So angle between both will be equal to 0 degree. On the other hand, if both are moving in opposite direction, then angle between both will be equal to 180 degree. Okay, so here angle is 0, and you know that F is equal to BQV sine theta. As both are in same direction, theta equal to 0 degree, and sine 0 is also 0. This means F equal to 0. So in both cases the force will be equal to 0. I hope you understood. Next question is, what happens to dipole moment? Very important. Two questions are here. These two questions are very important. What happens to the dipole moment of bar magnet if it is cut into two pieces parallel to its length? So two questions are here. One is when it is cutted parallel to its length, and one you will cut it transverse to its length. Students, if you have magnet, for example, I have taken this magnet. Okay, one is north pole, one is south pole. Similarly, one more magnet, north pole and south pole. So if you will cut it like this, means from center you will cut lengthwise, it is known as that you are cutting it parallelly. If you cut it in parallel direction, but if you will cut it in this way in center, then this is known as transverse. Okay, so there are two questions, one is parallel and one is transverse. Get it? So first we will do parallel, that when it is cut it in when we cut it in parallel, then what will happen? Okay, so when you will cut it in parallel direction, so what will happen? Students, you know that magnetic dipole moment is denoted by capital M. Okay, and capital M is equal to small m, means pole strength, multiplied by a 2L. This is magnetic dipole moment. Okay, so when you are cutting it in parallel, then what will happen to strength? So after cutting, m dash, means new strength will be half of the original strength. Okay, once again I'm telling you that new strength will be half of original strength. What happens to length? Parallelly means length will not change. Is it or not? So the new length will also remain 2L. Original length was 2L, new length also remains 2L. So what will be new magnetic dipole moment? It will be m via 2 multiplied via 2L. Is it or not? Okay, so that means if I will rub this upper part, I'll write here that what is the value of m dash? M dash is equal to 1 by 2 small m into 2L, and small m into 2L is capital M. That means m dash is equal to 1 by 2 times m. So if you'll see, then the magnetic dipole moment will remain half of original magnetic dipole moment. So this is if you will cut it to the parallel of its length. If you will cut it transverse to its length, then what will happen? If you will cut transverse to its length, then also magnetic dipole moment will remain half. But how? So let us see. Now you are cutting it transverse to the length. That means this magnet is there, you are cutting it from center like this. So what will happen? Pole strength of north and south is not affected. So that means m dash will remain m. But now L dash will be half, means 2L is the original. So it will be divided by a 2. I will not cut 2 and 2 because later I need it. So what will be capital M dash? It will be equal to small m multiplied by a 2L divided by a L. Okay, so now again I will do the same. This 1 by 2 I will take in front, and then I will solve. So you can see that capital M dash, it will be equal to 1 by 2 small m into 2L. So this is your magnetic dipole moment. That means m dash is equal to half of m. So in both cases the dipole moment remains half, but the procedure for both is different. एक में आपकी strength half हो जाएगी और एक में आपकी length half हो जाएगी, but ultimately you will get the same result, that dipole moment will remain half. So if the question will come for MCQs, you have to write only answer that it will remain half. But if the question will come for 2 marks or 3 marks, then you have to solve it stepwise. Okay, let us proceed towards the next question. Find the angle dip when horizontal component is, okay, horizontal and vertical components are equal. So I told you the formula, tan delta is equal to BV upon BH. Okay, so now tan delta we have to calculate delta. We don't have to calculate tan delta. It is given in question that VV is equal to BH. BV is equal to BH. Given that VV is equal to VH. So what will be tan delta? Both will cancel. So it will be 1. At what angle tan is 1? So tan is 1 at 45 degree. So that's why delta is equal to 45 degree. So this is your answer. That dip is equal to 45 degree. You can see in your notes as well. So this is very important. And 2 more important questions I told you about dip. That what is the dip at equator? 0 degree. What's the dip at poles? 90 degree. Okay, so next question is, what is shunt? What is shunt? And write its units. So I told you when we did that conversion of galvanometer to ammeter and voltmeter, that to convert galvanometer into ammeter, we have to convert to a very low resistance in parallel. and that low resistance is called as shunt. So shunt is the low resistance or small resistance which is connected in parallel to galvanometer to convert it into ammeter. So it is a resistance, so its unit is ohm. Next is, can you accelerate neutrons by using cyclotron? So answer is no, because cyclotron can accelerate only charged particle, and neutron is not a charged particle. It carries no charge, it is neutral. It cannot and cyclotron cannot accelerate electrons. Why? Because of its small mass of electron is very small, and if you will try to accelerate it with the help of cyclotron, it will go out of step and it will get lost. ओके, सो न्यूट्रॉन को भी नहीं कर सकते हैं, इलेक्ट्रॉन को भी नहीं कर सकते हैं एक्सेलरेट साइक्लोट्रॉन से. रीजंस यू मस्ट नो. न्यूट्रॉन के पास चार्ज नहीं है और इलेक्ट्रॉन के पास चार्ज है बट उसका मास स्मॉल है. व्हाट्स द मास ऑफ इलेक्ट्रॉन? 9.1 into 10 raised to power minus 31 kg. Okay, so students, next is key points, some formulas related to same units. So please go through these key points and do write in your notes notebook. This is enough for today. I hope you enjoyed today's class. From tomorrow we'll start our unit 4, that is electromagnetic induction. So this is enough for today. Thank you. Have a good day.